In this video, we're going to go over the distributive property, which is one of the most widely used properties in all of algebra. It's used to solve equations, multiply polynomials, and factor polynomials, among many, many other things. So it's an extremely powerful property, and it's something you should definitely know about. So let's explore the distributive property by using what's called the area model, which is a fancy name for just saying we're going to calculate the area of some shape. In this case, it'll be the area of a rectangle. So here's a rectangle, and if you recall your area formula, area is just, or this is the area of a rectangle, the formula is just, area is just the length times the width. So length times width. And in this rectangle, we're going to say that the width is a value a, and we're going to split the length up into two parts. So let's pick a point right here. We're going to say that this distance is length b, and this distance right over here is length c. And so the length of the rectangle is going to be the sum of length b and length c. So now we can express the area in terms of these variables. So we could say that the area equals the length times the width. And what's the width? The width in this case is a, and the length over here is the sum of b and c. And so we've expressed our area. So a over here is our width, and b plus c is the value of our length. Area equals length times width, or a times the sum of b and c. Now, there's another way of looking at this area. Let's say we were to take this line. Let me use the right color there. Let's take this point and draw a line right down here. And we're going to split the rectangle into two smaller rectangles. We've got a rectangle right over here and a rectangle here, each with its own area, the sum of which is going to be the area of the entire rectangle. So what we're going to do now is we're going to calculate or derive the area of this first section of the rectangle. And that's just going to be length times width, or in this case, a times b. So that's going to be area AB. And over here, we've got the same width, a, against the length c. So both of these rectangles have the same width. They've got width a here and width a here. It's almost as if the width a is distributed along the length of this rectangle. So because this width is a and this length is c, the area of this part of the rectangle is a times c. And so we can say that the area is the sum of AB plus this second area, AC. So let's write that out. So the area of the rectangle can also be expressed as the following. A times B plus A times C. So we've got two ways of expressing the area of the rectangle. A times the sum of B and C, and AB plus AC. And this leads us to an interesting conclusion. Now we can say that A times B plus C equals the area of the rectangle. And another way of expressing the area of the rectangle is A times B plus A times C. And so because both of these ways are equal to the same value, the area, we can set them equal to each other. A times B plus C equals A times B plus A times C. And this can be illustrated using arrows. So we'll draw an arrow from A to B, because that's the first multiplication that we're going to do. We're going to distribute A to the B term. That gives you A times B. And then we're going to multiply A times C. And that gives you AC. And that is the distributive property. And we can use this property to manipulate expressions and change their form. So now we're going to try a few examples of some expressions for which we can use the distributive property. So let's take a look at 3 times x plus 5. Now this is definitely in the form of a times b plus c. So 3 is like our a, x is like our b, and 5 is like our c. And so what we're going to do is we're going to distribute the outside term 3 to both inside terms. 3 times x equals 3x, and 3 times 5 equals 15. And so we use the distributive property. To distribute out this outside term. And so we use the distributive property to change the form of this expression and to get rid of these parentheses. So let's take another example. Let's say we had negative 5 times x plus 3. And I'll do this one more time. All right, negative 5 is like our a, x is like our b, and 3 is like our c. And now we can start distributing the outside term. Negative 5 times x equals negative 5x. And negative 5 times 3 is just negative 15. Oops. Is just negative 15. And let's try two more. Let's do 2 times x minus 4 equals, we're going to take our outside term, multiply it, that's going to give me 2x, and then 2 times negative 4 is going to give me negative 8. And there we go. All right, last one. We've got negative 4 times x minus 3. All right, what's going to happen here? We're going to take our negative 4 and multiply it by x, and that's going to give us negative 4x. And then we're going to take our negative 4 and multiply it by a negative 3. It's important to remember this is not 4, but it is negative 4. That's not a subtraction sign. And this is not 3, but it's negative 3. It's not a subtraction sign. And as we know, a negative times a negative equals a positive. So we're going to write plus 12 here. Negative 4x plus 12, because it's a negative times a negative. All right, and so those are some examples of the distributive property. Now let's go over some expressions that can be simplified using the distributive property. So let's say we were given the expression 3 plus 2 times x plus 5. I'm sorry, x minus 5. How could we use the distributive property to help simplify this expression? Well, let's look at what we have here. We have the number 3. So that's a term all by itself, the number 3. And there's nothing really we can do with the number 3, so this is just going to be equal to 3, because there's nothing we can do with it. So what are we going to do with 3? Nothing. However, let's look at this other term that we've got here. It's not exactly a term, but it's an expression, 2 times x minus 5. That's all one thing. So let's look at that as if it were one expression. And we might notice that it is in the same form as that. It's in the form of a times b plus c. So what are we going to do? Well, we can use the distributive property to rewrite it as an expression without parentheses. So we're going to take 2 and we're going to distribute it to the x. So that'll give us a positive 2x. And then we're going to take 2 and distribute it to the negative 5. And 2 times negative 5 is negative 10. And so now we've turned this expression, 3 plus 2 times the difference of x and 5, into a different expression, 3 plus 2x minus 10. Now in this expression, we've got two like terms. All right? The term 3 and the term negative 10 are both numeric terms, and so we can combine them. 3 and negative 10 equals negative 7. And then with this 2x, we just have nothing happens to the 2x. It's still there. So we could say that this is equal to negative 7 plus 2x, or if you wanted to use the commutative property of addition, switch the terms around and say that you have 2x and negative 7. So that is how you would simplify this expression. All right, let's do one more. Let's say we had the expression 4 minus 6 times negative 8 plus 2x. How would we simplify that? So the first thing we want to do is we want to look at what we have. We have a numeric term 4. That's an expression all by itself. There's nothing we can do with 4. So we're just going to bring it down. And we're going to say we have 4. All right. The next part, we have to be very careful. We've got negative 6 times negative 8 plus 2x. All of this is one thing. That first number, that outside term, is a negative 6, not a minus 6. And then now we've got an expression that's clearly in the form of a times b plus c, where a is like our negative 6, b is our negative 8, and 2x is our c. So now we're going to distribute this we're going to distribute this negative 6 to change the form of this expression. So negative 6 times negative 8 is going to be positive 48. Negative 6 times positive 2x is going to be negative 12x. And now we've got two numeric terms, 48 and 4. 48 and 4. When you add those two together, you get 52. And over here, we still have our negative 12x. And of course, if you wanted to use the commutative property of addition, you could also rewrite this by switching the terms. You could say you have negative 12x and 52. And there's another example of simplifying an expression using the distributive property.